We can also use Mathematica to do this similar sort of solver type analysis. So again, the nice thing about Mathematica is we can just type this in a little bit more directly like the mathematical equation. So I'll choose I over nj equals, remember in Mathematica, and then the e function is capital EXP, square brace, minus, and I'm going to put this in as delta E for the energy over KB times T is how the variables I'll use. You could use your own. So that's sort of the equation that we have. If you want to automatically evaluate the initialization skills, you should always choose yes there. All the sort of functions I've provided are up there in those initialization cells. So click yes, and there's your equation. If you want it to look prettier, you could go in and use escape, capital D, escape, escape, little e, escape, to make it look like delta epsilon instead, if you prefer that, either way. And then we'll use solver on that. So solver, and then the arguments it takes are the equation and the variable we want to solve it for. So let's solve it for delta E. That gives us our equation, but that's not really what we want. We want to plug this in with some values in it. So I'll do the same example I gave in the video. Ni is equal to 0.1, Nj is equal to 1, Kb equals 1.381 times 10 to the minus 23, and we'll do T is equal to 298 Kelvin for now, and plug that in. And there it goes. It gives us our delta E in this case joules, since we put KB in joules. So this is the answer. Again, you can go back in. Let's say we know delta E, capital D, escape, little e, to get delta E is equal to, let's say, 2.1 times 10 to the minus 20. And we want to solve for Ni. We can just switch this here to solve for Ni. And so this is going to say, if Nj is 1, Ni is that sort of ratio, how many particles are in Ni compared to Nj. So 0.006, so about 0.6% of the particles are in Ni compared to Nj. So that's another nice little way to go through and do some of the algebra involved in these assignments.